Now we have here with us in Mission Control the lead increment scientist for Expedition 39 and 40, Yuri Guinart Ramirez, who is, again, the lead scientist for these both expeditions. And she's going to tell us a bit about what has been going on for Expedition 39 and what we can look forward to in Expedition 30. Thanks so much for joining us.
Thank you very much, Brandy. It's great to be here again talking about the science we're doing during increments 39 and 40. First of all, we had a very challenging first increment with a lot of systems, vehicle issues that had to be dealt with, but we were still able to accomplish great things during increment 39. One of the investigations that was fairly new for us, or brand new for us, was JAXA's hybrid muscle training.
Okay.
And we successfully completed that investigation with Commander Koichi Wakata performing these measurements. This investigation, as you can see, there's a picture there of the device. It's a much smaller way of exercising. And when we take the knowledge that we're gaining from the ability to exercise with a much smaller combination of equipment, it allows us to possibly expand to future planetary incursions with a much less bulky equipment to have to carry around to maintain the health of our astronauts and our crew.
So by using that kind of patch on the elbow that we just saw, that lets the crew exercise? How does that work?
Essentially, it's a electrical impulses are delivered into the muscles, and you have your eccentric and concentric muscles as you move in and out. In this case, they use curls as a movement, and as a crew member is exercising with the curls, the electrical impulses are delivered into the muscle, and they're taking measurements to see how well that preserves and conditions the muscle. And we will have our last data collection after the crew member comes home with their final post-flight BDC, as they call it, for a collection down on the ground. They'll measure the bulk of the muscle and how well the strength and the toning worked, and we'll see if this was a successful endeavor to help us, incursion more into more compact devices and ways to exercise. And this can be translated to Earth applications for a variety of possibilities, like folks that may be bedridden, that can't necessarily get out of bed and exercise. You might be able to help apply some of these counter measurement devices to help prevent muscle loss here on Earth, if we can pathfind that for the future. So it's exciting.
Okay, so that's an example of one that's ending with Expedition 39 as it ends. Is that the case very often, or is there a big changeover as one expedition ends and another begins?
There certainly is. There's a variety of disciplines, of course, that we research. In the human research category, we definitely have a very strong correlation to our crew members, because these experiments are essentially performed on the human body. So you are tied to that crew member for that. So that marks a big correlation to our human research footprint. There are other types of investigations that are obviously facility driven, and we have plant experiments and other microbiology experiments and crystal growth and so on that are not tied to the expeditions. So switching a crew member, it really isn't necessarily a direct impact as much as with the human research.
Well, how do you go about, prioritizing experiments, planning around these changeovers, and, as you mentioned, operational things that come up?
So we have a multilateral forum with the IRT, and this continues. We work together very, very early on the process, starting with the RPWG and putting together the complement. And as we get closer through the IRT multilaterally, we continue discussing the priorities for all the different partners and all the different investigations. I can tell you this first increment has been challenging, because we have to consider the human research aspects of an investigation. When the crew member comes home, that's our last opportunity to collect that data. And we have that window closing, if you would. And then we had SpaceX 3 overlapping with that, which had a lot of time-critical investigations that delivered time-sensitive research that had to be done within a certain amount of time. So that's where we put together all these different constraints and make sure that we can meet everybody's timing needs, and of course the balance to not forget about the other investigations that may be a little more flexible, but they're still important nonetheless.
Sure. Well, you mentioned hybrid training as one of the ones that went on during Expedition 39. What are some of the other new and exciting things that y'all got started during this past expedition?
We certainly had a very large complement arriving with SpaceX 3, and that would take quite a bit to go through all of them. It's difficult to choose, but we did have one exciting investigation called T-cell actin aging that came with SpaceX 3, and this was a very quick activation that had to happen after the arrival of SpaceX 3, and this will help us understand better immune impacts on the body due to space flight.
T-cell activation?
T-cell act in aging.
Actin aging. And how does that work?
Essentially, they're looking at folks were started to notice a trend. I think they looked back at some of the early space program flights and realized that close to 50% of the crew members that went on those Apollo missions had an infection developed either during the flight or within a week after returning. So that got some folks interested in that aspect, and they started to study, and they realized that microgravity has an impact on your immune system as a whole. So they flew these particular T cells, which are part of your immune system, to try to understand a little bit better how does microgravity affect that function. And we'll be looking forward to the results when SpaceX 3 comes back and see what we learned.
Okay. Well, I know you've got some interesting stuff planned for Expedition 40 as well. I think Opals is maybe one of the ones we've heard about. Can you tell us a little bit about that?
Yes, definitely. Brandy, switching gears to the external side of the house, we have the International Space Station is a great platform to observe not only the cosmos and the universe, but also back at our planet. And there's different kinds of investigations we have. Opals was delivered with SpaceX 3, and we've initiated the checkout for that investigation, and we'll be looking forward to do the actual science involved with it. In this case, we are exploring to gain a little more understanding of communication via laser. So we'll be able to transmit more data rather than with traditional radio waves through the laser. It's optical communications, and this particular device, Opals, will lock when the space station is flying over the JPL. It will lock in.
It's the Jet Propulsion Laboratory, one of the NASA centers in California.
Yes, thank you. It will lock in communications with the Opals device. Then that ground station will sync up, and once it's locked, it will transmit data through the laser.
It's very sci-fi. It sounds like a movie.
It does, doesn't it? It's like, ooh, communication via laser.
Lots of fun stuff going on board the space station. And actually, that reminds me, I think one of the other life sciences experiments that's coming up is called Force Shoes. Is that right?
Yes.
That sounds interesting.
I can think of a nickname or two. Yes, Force Shoes. That, interestingly enough, is another human research investigation. And we have, as mentioned, a lot of exercise devices on station to try to keep the crew conditioned and properly preventing the muscle atrophy that happens during microgravity. The Force Shoes is a device that will measure the dynamic loads as the crew member exercises. Essentially, we had an ARED, which is one of the resistive exercise devices. Currently doesn't have the functionality to working correctly to collect the data on the force impacting. So with these Force Shoes, we should be able to collect the information on the loads.
Here, where we would use those Force Shoes.
Yes, that's right.
Why is the load information important?
Because it will help the medical community and the research community understand how to better fine-tune that exercise protocol. So as you exercise, you are better able to understand, do these exercises more, less of that kind, and the forces will translate to help
So you can kind of
the
perfect
data.
exactly what you need them to do to stay healthy in space.
Exactly, and fine
Okay.
tune that. And I could see applications on Earth
Sure.
for the same capability for us to fine tune our workouts. So.
All right. Well, I think we'll be hearing a little bit more about that later in the week when we have another guest come speak with us. But before we go, any other experiments that you'd particularly highlight?
Well, we have several happening. As we mentioned, it's a very large complement profile. We did initiate HDEV recently, also with the
Okay.
SpaceX 3, and that will continue. That's high definition viewing of the Earth. With
That one got some attention. I think a lot of people were interested in that.
I think it's generated some interest with the downlinks, and that's great to see the beauty of the planet being broadcast to the entire world, to be able to just click on it and look at it.
That is exciting.
That is very, very exciting. During increment 40, we'll continue with some of that. We also have a lot of work ahead with Robonaut 2. We have legs coming for the Robonaut.
Right.
So we'll be looking forward to increasing the capability by attaching the legs.
Speaking of science fiction, yeah.
And keeping with our science fiction theme, and check out some of the mobility capabilities for Robonaut. We'll have other investigations with Orb 2 arrival. We will continue our CubeSat deployers.
Okay.
NanoRack CubeSat deployers will bring a suite of satellites to continue exploring that capability. And we're looking forward to Orb 2 delivering a few. I think the image right now is showing the Orb 1 set of satellites.
And deployment of one of the satellites there.
So we're looking forward to more.
Okay.
More of those.
Well, it sounds like there's lots to look forward to, and probably we'll be hearing more from you in the future. Thanks so much for joining us. Again, this is Yuri Gnart Ramirez, who is the lead increment scientist for Expedition 39 and 40. And again, 39 wrapping up today with the departure of the Soyuz TMA-11M with its crew member going back to Earth to land in Kazakhstan this evening. That's all for now. We'll go back to our regular mission coverage. This is Mission Control Houston.